And so we need a way to be able to hold on and pair these socks. And in the same way that a chromosome is going to do that, we need a way to hold on to them. Okay? So I want to come back to these chromosomes over here. We've replicated them, but they're floating around. This doesn't really do us any good at all. And so instead, we're going to do something very different, which is we want to hold on to them. And we're going to use probably, I don't know, we could use tape. Let's just use rubber bands. Okay? And so we're going to use these circular structures here, these rubber bands. And as we make the chromosomes, as we're coming along, I'm just going to put a rubber band there to hold that together. Okay? Come along again, replicate, another rubber band. Continue to do that. As we're going, we're adding rubber bands along the entire length. Okay? The cell's probably a lot faster at doing this than I am. Do a couple of these rubber bands at a time. And build out to the end of the chromosome tree. Okay, so now we have a chromosome that is together. So now these are paired. I can really hold on to them. I've got a single physical unit, and it can move around. And this is actually a lot like what the cell is doing. Okay, so now we're going to walk through, again, the molecular players that underlie this as a process. And we're going to have to think about actually how we would achieve this. Okay. One other thing that I should point out is that these socks definitely are a good indicator of mitotic chromosomes. If this was your DNA, you'd have a really hard time with it. How do I actually use this to get in, to express genes and have RNA polymerase in there? It's pretty compact. I really can't actually see any of the DNA in there. And so it's important to recognize and acknowledge that all of our chromosomes are actually this. They're yarn. They're a long string of yarn. And ultimately, it's a conversion between this yarn, which is sort of loose and I can get stuff into, but still maybe organized by nucleosomes and other things. But I have to turn it into that. And so if instead I were to try to have as much yarn as I did each one of these things, it'd be an incredibly hard thing to distribute them. Very quickly, if I give you 7 balls of yarn, each duplicated, they're going to all come together in very, very complicated ways. And so we need to think about not only how we organize them by holding them together, but we organize them in terms of making them a structure that's actually more easy to physically distribute. Okay? And so for this, we're going to have a variety of things that we need to do. We're going to refer to these replicated chromosomes as sister chromatids. So one chromosomal unit is a chromatid. A sister chromatid is a replicated version of that. Now we have 2. They are the same. And we're going to have to think about how they pair, how they hold on to each other, and then also how we sort of compact them and organize them. And so we're going to talk about a process called condensation. Okay. And so basically the key thing here is that the DNA in your cells needs to be organized to facilitate its distribution. And the 2 key components of that, the first one is to be able to hold them together. And basically, if you replicate them, then you need to pair them. You need to make sure that they remain together and that they don't flow apart. Okay? And this really is a central thing in terms of assuring that you don't have random distribution, that you really get one copy in each new cell. Okay? And then the second thing that you need to do is you need to be able to compact the DNA. And this is so that it's not entangled during the distribution. And again, I want you to think about just sort of some of the numbers in this. So we talked about the process of having 30 trillion cells in our body. Each one of those cells, every single one of the cells in our body, the DNA is about 6 feet long. And that's a long length of DNA that's compacted into a very tiny space, just 5 to 10 microns in some cases. And so we definitely need to compact it normally to be able to fit it in there, and we need to further compact it when we're going to distribute it in this way. Okay? And so both of these processes, this process of holding and comparing and compacting, we're going to refer to this process as cohesion. And we're going to refer to this process here as condensation, basically bringing things together. And because the people working on this are excellent salesmen, we're going to have a key player in here, which is called cohesin, and a key player here, which is called condensin. Okay? So these are the molecules that actually drive this forward.